Very good morning, my dear students. Today we have to discuss the topic Coulombs Force in electrostatics. Before going to this topic, first I have to clarify a mistake done by me in introduction class of electrostatics. You just remember in introduction class we have read about charge and its properties. In that introduction video we have a discussion about charge and mass. In that video, the second point, the SI unit of charge is Coulomb and the SI unit of mass is kilogram, but it was mistakenly and read and also written was that the SI unit of mass was, we have written that is the charge and SI unit of mass is kilogram, but mistakenly it was just reversed. So first you have to clear our mistake. The SI unit of charge is Coulomb and the SI unit of mass is kilogram. So you correct accordingly. Then we have to come our today's topic, the Coulombs Force and the Coulombs Law in electrostatics. This is a very fundamental law of electrostatics. We have to proceed now. And this law was formulated by a great scientist, Charles Augustin Coulomb. In previous class we read that the two similar point charges always repel and two similar unlike point charges always attract each other. You see this figure? Here there are two charge bodies, plus Q1 and plus Q2, and they repel each other. Similarly, you see this figure, one is positive charge and one is negative charge. So they attracted each other always if they are point charges. First you have to mark the notation of force. Here you see F21 vector. That means force is acting on Q2 charge due to Q1. Similarly, F12 vector, force is acting on Q1 due to Q2. And you also see the direction of a force. What is the direction of force? I have written a line here and unit vector is represented r cap. Here F21 vector is along the direction of r cap and F12 vector is along the opposite direction of r cap. That means this is the direction of a minus r cap. Similarly here, the direction of a F12 vector is along the r cap and the direction of F21 vector is opposite to r cap. That means in this direction. Now you come to the law of Coulombs law. What? It is stated by Charles Augustin Coulomb. He states that this is a universal law that the two point charges, first to remember the charge should be point charges and stationary point charges. Stationary point charges means either both charges are rest or both are relatively moves with same velocity. That means they are relatively rest. So we can say that the 2 point stationary charges, like charges or unlike charges, they will repel or attract. The amount of a force is directly proportional to product of the charges and inversely proportional to the square of the distance between them. That means he explained that if the magnitude of charges increases, then force of repulsion or attraction increases. Similarly, if the distance between two charges increases, then force of interaction in between them decreases. Again we will come to this point, and mathematically, here you see these two forces are always equal in magnitude. Why always equal in magnitude we will discuss later. First to remember, these two forces are equal in magnitude. Say that magnitude is F. But you observe that the direction of these two forces always opposite to each other. That means these two forces are of same magnitude and opposite direction. That means they are negative vectors. So I have written here. If you want force direction towards r cap, then another force direction towards minus r cap. So before going to formula, first to keep in mind this force of attraction or repulsion is same magnitude and opposite in a direction. And you should keep also remember that the direction of this force is always along the line joining of two charges. Here we have notation is r cap. Now, according to Coulombs law, what he says? The amount of a force, that means magnitude of a force, is directly proportional to product of their charges and inversely proportional to the square of the distance between them. If you will combine write this notation, F proportional to Q1 into Q2 by R square, and if you will keep a proportionality constant, here we have named as beta. F is equal to beta Q1 into Q2 by R square. This is the formula of Coulombs law in magnitude form. If you will write this formula in vector form, that means we have to represent a direction here. According to our vector concept, every vector can be represented at first you write magnitude, then you write unit vector. So here magnitude is beta Q1 into Q2 by R square and multiplied by unit vector. So this is the form of magnitude form of Coulombs law, and this is the form of vector form. As like in your gravitational force, F is equal to m capital G m1 into m2 by R square. Here it is written beta. So again come to the statement of Coulombs law. The force of attraction or repulsion in between two point stationary charges. I am repeating the word, two point stationary charges is directly proportional to product of the charges and inversely proportional to the square of the distance between them. Then we come to our point. You also now clear why F12 vector mode is same as F21 vector mode. Very simple mathematical logic is here. Here you see F proportional to Q1 into Q2. Product of the two charges. That means 5 into 2 is same as 2 into 5. That means scalar quantity product obeys commutative law. So if force acting on Q1 is same as if you had, for example, if force acting on Q1 is 5 Newton, then force acting on Q2 will also be 5 Newton. Whether the Q1 and Q2 magnitude is different or same, that is not matter, because in the formula you just remember, if beta kept constant, distance remain constant for a given distance for a given medium. F is proportional to Q1 into Q2. Force acting on Q1 due to Q2 is the same as force acting on Q2 due to Q1. A very simple answer should be like that. The product of the two charges Q1 into Q2 is the same as Q2 into Q1. So it does not matter whether the charge Q1 is greater and Q2 is smaller. If they are kept in same distance, force acting on Q1 is also same as force acting on Q2. This is the basic law of electrostatics. Then we will go and discuss on what are the limitations of Coulombs law. Very sentence it is mentioned that point charges and stationary charges. This is the limitation of Coulombs law. Limitation means for that condition Coulombs law is valid. First condition is charge should be point charges. What? Charge should be point charges. Second condition is charge should be stationary charges. Stationary charges means either both are at rest or both are moving with constant velocity. That means two charged particles are relatively rest. So this is the basic formula of Coulombs law. Magnitude form in vector form, and this is the limitations of Coulombs law. And statement, always you remember that whenever exam or any matter question comes, you should remember this law that the electrostatic force of interaction in between two charged particles is directly proportional to product of their charges and inversely proportional to the square of the distance between them. Now we have to discuss what are the characteristics of the electrostatic force. This is a very fundamental force in electrostatics. First property, it should be charge dependent. You recall the formula F is equal to beta Q1 into Q2 by R square. Charge dependent means the force of interaction is directly proportional to the product of the charges. If the magnitude of the charge increases, then according to this law, the force also increases. That means force is charge dependent. Central force, we have already discussed in nuclear force and gravitational force, central force and non-central force. Here again we are repeating here, as like gravitational force, the electrostatic force is also central force. First we remember what is central force. Now the force which obeys inverse square law. Inverse square law means here the law states that F proportional to 1 by R square. If you represent mathematically 1 by R square means R to the power minus 2. Minus means inverse, 2 means square. So this law obeys inverse square law. Hence this is a central force. Name center is attached here because this R represent the distance between center to center mean between two charges. That is name is mentioned here. But if in question comes what is central force, so your language should be the force which obeys inverse square law. Electrostatic force is an example of central force. In 11th class we have studied that the gravitational force is also an example of central force. So our electrostatic force, first property is it should be charge dependent. Second property is it is central force in nature. Then another point, conservative force. We have already also discussed conservative force. Conservative force means work is independent of path. Here the electrostatic force is a conservative force. What is it? How work is independent of path? Let's see the example. This is a source charge, say Q. Here there is electric field around this charge. If another charged body I will kept here, then this source charge either attract or repel according to their nature. Let this one is positive and this one is positive, so repulsive force is acting on small q. So if a charge, test charge, is kept in the electric field, so it will experience a electrostatic force. Conservative force means if this force from this point I have taken to this point, number 1 point and number 2 point, in this way I have taken, some amount of work will be done because force is acting on it. let this amount of work is 10 joule. Now another example, same charge q is taken from this point to this point in another path, same amount of work will be done. So here you see that the work done by this path is 10 joule, work done by this path is also 10 joule. That means work done is independent of path. And this work is done by which force? The electrostatic force. So electrostatic force is a conservative force. Now a question comes to your mind, sir, how work is independent of path? Okay, this answer will be cleared when we will discuss the motion of charge particle in the electric field and the calculation of work. At that point, at that time, we will also clear how work is independent of path. Now you keep remember what is conservative force. If work is independent of path, any question when sir will ask or exam will ask what is conservative force, your language will start from work. If work is independent of path, force against that work is conservative force. Now you just remember the property of electrostatic force. One of the properties is conservative force. Now next point, it depends upon the intervening medium. How it depends the intervening means interval, middle medium. Here charge q1 is here and charge q2 is here. This represents medium in between two charge particles. Statement that it depends upon the intervening medium. For example, I will say you sodium chloride Na plus Cl minus. These are two charges. So they will attractive force will be act here. If the sodium chloride will kept inside the water, attractive force will be developed, but it will decreases. What else I am saying? It will decreases. So you kept in mind, when sodium ion and chlorine ion is kept without medium, some force is developed, you can calculate by this formula. When the same sodium ion and chlorine ion is kept inside the water, so force will be different. If you will ask whether force increase or decrease, without calculation we can give the smart answer, sir, force will decrease. How will you know that? Now in chemistry you know that the electrolysis, dissociation of ions, sodium chloride and sodium chloride solution, luno pani. The dissociation is very easier in case of sodium solution because medium is kept water here. The electrostatic force of attraction in between sodium and chlorine ion decreases. So our discussion point is that whether the electrostatic force depends upon the intervening medium or not. So you should say that yes, it depends upon the intervening medium. It will not change the amount of charge, it will not change the distance between them, but force changes if the medium changes, because the electrical property of medium is different from one medium to another medium. So this proportionality constant beta depends upon the property of the medium or nature of the medium. Okay. Now this next property, the nature of the electrostatic force. It may be attractive or it may be repulsive. Attractive if they are unlike point charges. Repulsive if they are like point charges. Now we have to discuss the last property. It obeys the principle of superposition. First to keep in mind all the forces as they are vectors. All the vectors obey the principle of superposition. Superposition means here the addition of vectors. I am just giving an example here. Here there are so many charges are there. In black spots, black dot mark, so many charges are there. One is Q1, one is Q2, one is Q3 and one is Q4 and other charges are also there. We have not mentioned here. Now our problem is that we have to calculate the total electrostatic force. Total means vector sum. Total electrostatic force acting on this charge. How can we calculate? If we will problem comes. Now first you see Q3, here is Q1, both positive. So Q3 is develop a force F31, that means force is acting on 3 due to Q1 in this way. Similarly, force is acting on 3 due to 2 in this way, and a force is acting on Q3 due to Q4 in this way, attraction or repulsion. Just 3 forces you are seeing. So many forces are there. If you calculate resultant force, so first to write in vector notation, this is the vector sum of all these forces with notations. So I want to write this vector in a dummy indices in summation symbol. How can you write here? First indices with the 3. Second indices is 1, 2, 4, 5, etc. That is dummy indices. Dummy indices means variable indices. So I have named it J. And here J value varies from 1 to n. So force acting on F3 vector, it is represented as vector sum of F3J vector. Similarly, if you will write F4, so will I write F4J. Let the instead of 3, I write here the force is Fi vector. And dummy variable is J. So its notation is Fi vector total is summation over Fij vector. I is not equal to J, because here you say F33 vector is not here, because 3 and 3 each charge does not develop force on itself. So you have written I not equal to J. Very simple. The laws of principle means the vector sum of, if in problem the total electrostatic force more than 2 vectors or more than 1 vector, so by using vector law, triangle law or parallelogram law or by component method, we can add all the vectors and we can also calculate the magnitude and the direction of the resultant force. And this principle is known as principle of superposition. Just I am recalling what we have studied. The electrostatic force, first property is it is charge dependent, and second property is central force, that means it obeys inverse square law, and third property is conservative force. These two properties are important, central force and conservative force. Next property is it depends upon the intervening medium in between two charged particles. Nature may be attractive or repulsive. As like all the forces, it obeys the principle of superposition. Now we come to another point here. How can you represent the Coulombs force expression in free space? Free space means vacuum. There is no medium particle is present in between two charged body. Notation should be like this. F naught is equal to beta naught Q1 into Q2 by R square. Beta naught represent the proportionality constant in free space. F naught represent the expression of electrostatic force in free space. First we write in SI system. How will write in SI system and vacuum? Before going to write the expression, first you should remember what is the value of a proportionality constant in vacuum in SI system. Always exam this value comes, write the value of beta 0. That means proportionality constant in Coulombs law or Coulombs force in SI system and vacuum. You should remember from experiment it is calculated, but you should remember it always helps in a problem, that is 9 into 10 to the power 9 Newton meter square per Coulomb square. Numerical value you have to always remember. Unit, if you does not remember, no matter, it comes from formula also. You see the formula. Beta 0 unit. So R square is multiplied here. Newton and R square is multiplied here. Newton meter square. Q1 and Q2 comes here. Q1 means Coulomb, Q2 in Coulomb. So beta 0 unit SI is Newton. If it is multiplied there, Newton meter square divided by Coulomb square. So if you will forgotten, there is no matter. If you will come to this formula and you get the unit. So the value of beta 0 or proportionality constant in SI system, that is 9 into 10 to the power 9 Newton meter square per Coulomb square. And it is represented by this notation 1 by 4 pi epsilon naught. New symbol is added to E. epsilon naught. What is epsilon? What is epsilon naught? We will discuss later. Just to remember, 1 by 4 pi epsilon 0 also can be expressed. Exam also always comes, write the value of 1 by 4 pi epsilon 0. So you should write 9 into 10 to the power 9 Newton meter square per Coulomb square. Now come the expression of Coulombs force in SI system. F naught is equal to 1 by 4 pi epsilon 0 Q1 into Q2 by R square. So you write in your formula copy this formula, and this formula is used vacuum in SI system. Similarly, the formula in electrostatic unit, or you may call it CGS unit, in vacuum, the proportionality constant value is different. In SI system, its value was 9 into 10 to the power 9 Newton meter square per Coulomb square. In CGS system or in electrostatic unit, its value is 1 dyne centimeter square per start Coulomb square. Instead of Newton, we have written dyne. Meter square instead we write in centimeter square. In Coulomb square instead we have written start Coulomb square. And numerical value changing. In SI system that was 9 into 10 to the power 9. In CGS system it was 1. So in CGS system expression will be F0 Q1 into Q2 by R square in electrostatic unit. These two formula is very important while doing the problems. Students always make a mistake, always use this formula whether it is SI or CGS. But you should remember in SI notation we have to retain 1 by 4 pi epsilon 0 Q1 into Q2 by R square. In CGS system, so formula will be Q1 into Q2 by R square. Why? Now this proportionality constant is different in SI system value, in CGS system or in electrostatic unit its value is different. So you should not forget about these two formula while doing the problems in electrostatics. It is very important in SI system or in electrostatic unit. Now just we have a discussion what is electrostatic force and gravitational force. As like we have discussion the distinction between charge and mass. You keep the point carefully. First going to discussion, you keep the formula here. The electrostatic formula is F is equal to beta Q1 into Q2 by R square. And here formula is F is equal to G M1 into M2 by R square. From formula some points are very clear to us. Electrostatic force is charge dependent and gravitational force is mass dependent. And its nature may be attractive or repulsive, and its nature is always attractive. If you will compare the formula by two charged body, if you will calculate electrostatic force by using this formula, if you will calculate the gravitational force by using this formula, so magnitude will be different. Which one will be greater and which one will be smaller? Now the magnitude of electrostatic force is greater and the gravitational force is less. So here is written the magnitude of electrostatic force greater than the gravitational force. Here just reverse, the magnitude of gravitational force is less than the magnitude of electrostatic force. For this we also give an example to you when a charged comb is kept very near to neutral paper pieces. I have also explained that the electrostatic force is developed due to induction method of charging. In spite of gravitational force, the paper sticks with the charged comb. This experiment also showed that electrostatic force is greater than the gravitational force. Now next property, the electrostatic force depends upon the intervening medium because the proportionality constant depends upon the intervening medium. So if the medium changes, the electrostatic force changes. But in gravitational case, there is no change in gravitational force if the medium changes, because the proportionality constant is known as universal constant. It does not change if the medium changes. So electrostatic force depends upon the medium in between two charged body, but the gravitational force does not depend the intervening medium in between two massive body. And also you also remember that if any medium comes to the in between two charged particle, the electrostatic force changes. That means always decreases. Why decreases? You can calculate by the formula, and another formula is also there. You can also explain why decreases. Now we have to discuss the similarities in between electrostatic force and gravitational force. Both the forces obey central in nature because it obeys inverse square law. F proportional to 1 by r square here, F proportional to 1 by r square also here. Conservative force, both the forces are conservative. That means work done by the respective forces are independent of path. As both the forces are vectors, so to obey the principle of superposition. These are the decimal point, 4 points, and these are the similar points in between electrostatic force and gravitational force. Now the new form symbol we have studied, that is epsilon naught, and epsilon we have to discuss what is that epsilon, what represent here. First to acquainted with a new word, that is permittivity, and it is noted as epsilon. When I use this notation, you just recall today I have discussed the electrostatic force in vacuum in SI system. It is written as 1 by 4 pi epsilon 0 Q1 into Q2 by R square. F naught is equal to 1 by 4 pi epsilon naught Q1 into Q2 by R square. This formula is applicable for vacuum. So notation here, not here or 0 here. If you will replace any other medium, so will be notation will like that. If you will write water, then it will write epsilon water. If you will write paper, so you write epsilon paper. But if you do vacuum, so you write epsilon naught. So epsilon naught represents the permittivity in a free space. Epsilon represents the permittivity of any medium what you have chosen. Now you see epsilon what represents. First it vary from as medium to medium, so it represents property of a medium. First what we guess, epsilon is the property of medium. Here what property it defines? Now you see the formula. If we will increase the epsilon, the electrostatic force decreases. So this property signifies the electrostatic force, increase or decrease. What we will guess, increase or decrease? Decrease, because formula is like this. If you will increase the epsilon, then the electrostatic force decreases. So we can say that what is permittivity? Now first you say that it is a electrical property of the medium. It is a property of medium, but you can say that electrical property of the medium because it measures the electrostatic force in between two charged particles. So if in language you will say that what is definition comes, this is definition we are discussing. What is permittivity? So you say in your language, this physical quantity which represents electrical property of the medium is known as permittivity. If another question comes, how it depends the electrical property? It depends inversely proportional with electrostatic force. If you increase the permittivity, then electrostatic force decreases. So I am again repeating the definition. What is permittivity? Permittivity of a medium is defined as its electrical property of the medium. With increasing permittivity, the electrostatic force in between two charged particles decreases. This is the simple definition of permittivity. Now we will discuss what is the unit and dimension of the permittivity. First to see the unit. I have written in SI unit Coulomb square Newton meter square. How it comes? Now you see the formula here. You want to give the unit of epsilon. So you keep this epsilon here. If you will keep this epsilon here, so epsilon is equal to 1 by 4 pi f Q1 into Q2 by R square. So how will the SI unit? Q1 into Q2 means Coulomb square. F means Newton. R square means meter square. So SI unit is Coulomb square Newton meter square. In SI format you can write Coulomb square Newton inverse meter to the power minus 2. Another unit is also attached here. It is read as Farad meter inverse. How this unit comes we will discuss later when we will discuss about Farad. Now you can understand this unit and use this unit. If you do not remember, then you come to formula, you can easily calculate the unit of epsilon. So SI unit is Coulomb square per Newton meter square. And if you will make the dimension of this permittivity, then you come to the formula Q1 into Q2, and you recall the dimension of charge A1 T1, that means current into time. Q1 into Q2 means S square T square. F dimension you have already remembered in 11th class, M1 L1 T minus 2. R square means L square, and if you will reduce to this formula, your dimension will be M to the power minus 1, L to the power minus 3, T to the power 4, A to the power 2. Always you remember, does not keep in memory the dimension of a permittivity. Dimension always calculated from the formula. So you should keep in your memory that formula, not the dimension. If you keep in your mind in formula, it helps in problem, it helps to define a physical quantity, it also helps in to calculate of a unit, you can also easily calculate the dimension. So formula is very essential for you when you are doing the problems or any answers given to your questions. So always I am telling that you will make a formula while you studying simultaneously. Formula copy must be needed, and always in every day you should keep an eye what the formula you have read. Okay, now you have to keep in memory the value of a permittivity in free space. It is calculated from the experiment. This formula, this value always asked in a board exam. The value you should remember that permittivity in free space, epsilon naught. Free space means vacuum, 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square. Another value also I have discussed, what is value of 1 by 4 pi epsilon 0. 9 into 10 to the power 9, and unit is Newton meter square per Coulomb square. You see the units are just reversed. Here unit is Coulomb square per Newton meter square. In that case the unit is Newton meter square per Coulomb square. Here the numerical value is 8.85 into 10 to the minus 12. In that case the numerical value is 9 into 10 to the 9. Sometimes comes in exam epsilon naught, and sometimes always exam comes 1 by 4 pi epsilon 0. Then we have to discuss the relative permittivity. Permittivity we have to compare. Relative permittivity means permittivity of any medium is compared with permittivity of vacuum or free space. So formula is like that, epsilon by epsilon naught. So definition should be like that. Relative permittivity of any medium may be defined as the ratio of permittivity of any given medium to the permittivity of free space. It is notation, is another notation is there, K. It is known as dielectric constant. What is dielectric constant we will also discuss in later, but the numerical value of K is same as epsilon r. So you can use the two notations, either you can use epsilon r or you can use K. Epsilon r represents relative permittivity, K represents dielectric constant. Yet it is a pure ratio, it has no unit and no dimension. In exam this question also come, the value of relative permittivity or dielectric constant in free space. Free space means you are comparing the free space with free space, so ratio will be 1, no unit. And you can also add these two value. The epsilon relative permittivity for water is 80 and relative permittivity of metal is infinity. How it is 80 and infinity, when we will discuss the dielectric constant, we can also explain you. So we know what is permittivity, what is value of a permittivity in free space, and relative permittivity and value for different media. Now there is another important formula for you, that is Coulombs force in any medium. How we will write the Coulombs force in any medium? First to remember how we will write the Coulombs force in vacuum. In SI system we can write F naught is equal to 1 by 4 pi epsilon 0 Q1 into Q2 by R square. I keep this equation number 1. If you want to this formula in any medium, instead of epsilon naught you just give the notation epsilon. Then you change this epsilon. How will you change? Now you just read that epsilon r is equal to epsilon by epsilon 0. So epsilon will be epsilon r into epsilon 0. I just posting here, instead of epsilon, epsilon naught into epsilon r. Epsilon r kept outside. So inside the bracket 1 by 4 pi epsilon 0 q1 into by q2 r square. And this one is obtained from this equation 1, that is F0. So Coulombs force in any medium can be expressed as F0 by epsilon r, or you can write F0 by epsilon r, or you can write F0 by k. So if any problem F0 is given and you have to calculate F, then you use this formula. Answer will come very fast. So how conclusion what will get? F is equal to F0 by k or epsilon r. For any medium, the relative permittivity is always greater than 1. As this value is greater than 1, so you can write F less than F0. That means if there is two charged particles, Q1 and Q2, and you calculate F0, that means no medium is there. If medium will be changes, then it will be F, and this value is always less than free space. So Coulombs force is a maximum in free space. If changes the medium, you keep in mind, exam also this type of question comes, in any medium the electrostatic force decreases. How it decreases, you can explain by this using formula. So today we have discussed the important topic, that is electrostatic force or Coulombs force. This is a very fundamental force formulated by Charles Augustin Coulomb, and the formula states that the force of interaction may be attractive or may be repulsive in between 2 point charges is directly proportional to product of the charges and inversely proportional to the square of the distance between them. And you keep in mind the formula is F is equal to beta q1 into q2 by r square. And beta value changes if the medium changes. In SI system you write beta is 1 by 4 pi epsilon 0. In CJ system beta is 1. Then you do the problems taking all the properties of electrostatic force. When we discuss the problem next class, so we should clarify about this law and this formula. Thank you all.